Welcome back, folks. We can do all of the circuit analysis we did with DC sources with AC sources. That means we can do mesh. That means we can do nodal. Here's an example of mesh. It's stated a little differently. You might see this in textbooks. You might see this on exams, FE exam, things of that sort, where it's already in the phasor domain. So we're not working from the time domain to the phasor domain. So something like this would simply say find V out. Okay, and we got to go find V out. And hey, there it is. Okay, that's J2. I'm sorry, that's kind of... You're getting some unedited stuff out of my half-written textbook. So it's not always camera ready. Neither am I. Okay, so it's already in the phasor domain halfway there, right? So let's do mesh analysis. Near and dear to my heart. So let's get two meshes, I1 and I2. Okay, I see one current supply, so I'm going to write one KCL and I'm going to write one KVL. And that current supply doesn't share currents, so it's not a super loop. So that's nice. It's the simpler of the cases where I have to write the KCL. So let's start here writing the KCL for I1. Okay, and let's see, we go up VS, we go down R1, I1, we go down, and we got to be careful with this. Look at that, negative J4. We're going down because of the passive sign convention. Okay. Oh, I didn't need that second set. You'll see why in a second. Okay, so we're going down because we're dropping, but we're going across a negative J4. So it's really easy to make this mistake. So we drop because of the KVL, and then we're dropping across negative J4. Okay, so it might be a little safer. Let's do it this way, to call that Z sub C. And the current is then I1 minus I2, just like it was before with mesh. Okay, I'm going to run out of room there, so I'm going to wrap my equation, and we get negative R2 I1 minus I2. And that's equal to 0 since I'm back to where I started. That's our first equation. We've got to manipulate that a little bit. And we got to be a little careful because we've got these complex numbers to deal with. But let's drag this down here. Okay, and let's say, what do we have in front of I1? We've got negative R1, negative ZC, and negative R2. All of that in front of I1. And then in front of I2, we have positive ZC and positive R2 in front of I2. And then VS ends up popping over to the other side. Okay, so if we just plug in some values here, we can get a coefficient for I1, we can get a coefficient for I2, we got a constant over here. We've got constants and we've got our unknown mesh currents, just like we did before. The constants are now complex numbers. That's the only difference. Okay, so let's see. Let's plug in the values here. Pause the video with me and try it out on your calculator. Make sure you can get the same value when it counts. I didn't even finish doing it on my calculator. I can do that in my head, right? Negative 4 and negative 2 gives me negative 6. And then negative ZC is going to be plus J4, right? The negative here cancels the negative there. So I get negative 6 plus J4 in front of I1. Okay, and let's see, ZC is negative J4 and R2 is 2. So if I'm writing this in the usual way, it's going to be 2 minus J4. And that's in front of I2. And then this would be negative 12, but by convention, we don't always write negative 12 at an angle of 0 degrees. We try to keep the magnitude positive and we flip the angle. So we could write this correctly as 12 at an angle of 180. Okay, if you remember from the review videos or your past experience with complex numbers. Negate it, you rotate it 180 degrees. Okay, so that's our first equation. That took a little while. Yeah, it's a little slower with these complex numbers. Okay, that's our first equation. Our second equation is the KCL. I might be able to fit it right above my head, you think? KCL for I2. Why did I write KCL up here? You were yelling at the screen, weren't you? You were like, hey, he's going to miss that. Wrong. This time. I caught it. Okay. We're writing a KCL for I2. Does I1 touch the current supply? Nope. Does I2? Yep. Same or opposite direction? Opposite. So it's negative, and that's equal to 4 at an angle of 90 degrees. Okay, that's our second equation. Two equations, two unknowns. You got to solve this system. So depends on the type of calculator you have. I'm hoping you have something worthwhile, but go solve it. I am going to pause it this time, and I'm going to throw it in my calculator and come out with a solution. I want you to do the same thing. Have I said that enough? I want you to practice with your calculator. So take this moment to practice. Okay, so from that system of equations, I get a solution for I1 is 1.24 at an angle of negative 82.9, we'll call it, and that's in degrees. Check the mode of your calculator, folks. I2 is, well, 4 at an angle of negative 90. Right, I said we negate it and we rotate it by 180. There it is. Okay, those are both in amps. I'm just going to double check that. Yep, those are both in amps. Okay, so I'm going to store those. And I'm going to store them because I really don't want to type them again if I can avoid it. So I have I1 and I have I2. I got to use those to find V out. I find it in the same way. The positive direction according to passive sign convention is down, right? Does I1 touch it? Yes, and it goes in the positive direction. Does I2 touch it? Yes, but it goes in the negative direction. So for V out, we have I1 minus I2 times R2. Okay, so let's plug in some values for that. And we can grab, cheat our way to glory, which I don't think you should actually do. Okay, we have that. We subtract 4 at an angle of negative 90. Okay, I find it good practice, certainly when I'm using my calculator. If I have a complex number, I throw it in its own set of parentheses. Not so much with polar, but with rectangular, you can really save yourself a lot of heartache if you go ahead and do that. Okay, and we're going to multiply all of that by 2 ohms, and that's amps times ohms is going to give me a phasor for volts. Okay, so I have I1 minus I2 times 2. Okay, so I find that V out is 5.55 at an angle of 86.8 degrees, and that's in volts. That's the best I can do. We started in the phasor domain. We got to end in the phasor domain. We can't move back to the time domain because we don't know the frequency. Okay, but if that's what was asked for, that's how you get it. All the same stuff applies with mesh. If we need to do super loop or super mesh, we know how to do that. We need a tool that can solve a complex system of equations. I'm hoping by now you found a calculator that can do that for you. Okay, if we can do mesh, we can do nodal, and that's what's coming up next. Stay tuned and good luck.